Chapter 10, Day 3. No real new information today. The next set of notes will give us one more new way to calculate this confidence interval. So today we want to make sure that we understand when to use Z star with table A, our probability table. And when to use T star. That's your critical values table. Now, the one I gave you is labeled as D, but that's not necessarily something that is consistent among all critical values tables. So when do we use Z star? Yeah, yeah, when the population standard deviation is given, right? When sigma is given or known. And I know I mentioned in this class, I think it's unlikely that in most life situations you're going to know what the population standard deviation is without knowing what the population mean is. I just find that unlikely. So when we look at our formula, x bar minus plus or minus z star, you'll have to excuse me, I'm not writing or thinking very well today for some reason. Sigma over root n. We've been using that formula to calculate this, and it's not a hard formula to use, I don't think, by any stretch, but there is in the TI-84 a shortcut. It's called the Z interval. And I will show you where that is. It's quite easy to find. It's somewhere that we haven't been before. We go to stats, and over here in tests, it's the Z interval. In this case, it's number 7. Now, there's a whole bunch of tests in here. We will learn just about all of these before you guys take the AP exam. None of these have come in handy yet, but this is pretty much second semester right here. Okay? All right. And how about T star? We use T star when? When we don't know sigma, right? When the standard deviation is calculated from the sample. When S, or in the calculator that calls it S of x, it's the same thing, is calculated from a sample. So that's our x bar plus or minus T star times S over square root of n. And in the TI-84, there's a shortcut for that too. It's in the same spot. It's right underneath the Z interval. It's called the T interval. And I'll show you how to use these today. It's quite simple. You'll probably want to strangle me for not teaching it to you sooner. But there's a reason that I didn't. Don't forget with T star, we always have to use degrees of freedom. And that is n minus 1. Or we round down. So degrees of freedom should always be rounded down when necessary. example of when that is necessary would be a situation where, let's say our n value is 49, and we look at our table and we go, wait a minute, there is no 49. Degrees of freedom would be 48. So, but I'm closer to 50. Should I round up? No, you always round down. So you'd take that to 40. Now, if you're using the calculator for this t-interval, it does all that for you. So if n is 49, degrees of freedom is 48. If we're using the table, we have to round down, but the calculator handles it at 48 just fine. It knows all those numbers. So the main reason we worked so long with these guys, and I didn't share with you these, is because I want you to recognize something. I hope that you've seen that the x bar, that is your middle of your data, right? The margin of error, whatever you choose for whatever you margin to be, your commons are 90, 95, and 99. This is this part, or this part of the formula. So the margin of error in one situation, m equals your plus or minus z star. Actually, it should be plus or minus m times sigma over root n. Or plus or minus the margin equals plus or minus t star times s over root n. Excuse me. So these parts here, that literally is telling you how much you add or subtract to that middle to get those outer bits for your confidence interval. The last thing I want to highlight, and again it's just kind of review more than anything else, is standard error. Standard error is a term that you'll probably see. You need to make sure that you know what that is when you see it. As a calculation, it's simply s, the sample standard deviation, divided by the square root of n. It's oftentimes referenced as SE for standard error, or sometimes we'll see that as SEM, and that SEM stands for standard error of the mean. And that's it.